and welcome back to my channel. So in the last video we were talking about methods of integration and we discussed a method of substitution. So in this video I'm going to talk about integration by partial fractions. So first let's understand what are partial fractions. Now if I have a function like this, I have a function p of x and also q of x. So as you can see, we have a rational function here. So this is called rational function. So we have the numerator and the denominator. So there are two types of rational functions. One is proper rational function. Proper rational function. So those are the functions where the degree of p of x is less than q of x, right? The degree. And then improper rational functions, the degree of p of x is greater than q of x. So what we try to do is we try to convert the improper rational functions to proper rational functions, and we further simplify it to make the integration easier. So let's solve an example to better understand this concept. So we have been given a question. We have to find the integral of x squared plus 1 whole divided by x squared minus 5x plus 6 and integrate it with respect to x. Now if I divide x squared plus 1 by x squared minus 5x plus 1, I'll get the remainder as, let's do the division process. It will be helpful for you. So I'm writing this in the divisor part and the dividend is x squared plus 1. Now what I try to do is here we can see we have x squared in the divisor as well as the dividend, so I just multiply it with 1 and I write down similar terms under this one. So we have x squared same, and minus 5x times 1 will be minus 5x, but we don't find any similar term here, so we just keep it at the side. But here 6 times 1 is 6, I'll write 6 under 1, and then subtracting everything we get the remainder as minus 5 plus 5x. So I can rewrite the rational function x squared plus 1 by x squared minus 5x plus 6 as 1 plus 5x minus 5 whole divided by x squared minus 5x plus 6. So we have simplified it a bit, and now we try to simplify it again. Now looking at the denominator part, we can see that we can rewrite this, we can simplify it further. We can rewrite this as we have 5x minus 5. So here let me see, we have to find the integral of this one. It will be equal to integral of 1 plus integral of this function. Both are with respect to x. So going back to this denominator part, we can simplify it and we can rewrite this as x minus 2 times x minus 3. So the method of integration by parts is that we can convert this one, we can rewrite this as a by x minus 2 plus b of x minus 3 to more simplify it and make the integration easier. So simplifying this one, we get a as minus 5 and b as 10. So therefore we can write that the whole partial fraction has changed into, we had x square plus 1 and x square minus 5x plus 6. So this has changed into 1 plus a is minus 5, so write minus 5 in the bracket, minus 5 by x minus 2 plus 10 in place of b, x minus 3. So we can see that we have simplified it a lot. Now we simply need to integrate it. So now integration by parts, we can simply do like this: integrate each term individually. So we can rewrite this. Finding the integral, we get integral of 1 is x, then we get integral of minus 5 is a constant, we'll keep it outside, and then we just need to find the integral of 1 by x minus 2. We can rewrite this as minus 5 by log of mod of x minus 2, then plus 10 log of, keep in mind that this is natural log to the base e, mod of x minus 3 plus c. So here we can see that I have written log of mod everywhere. And why do we do that? Let me show you that we know that 1 by x, and the integral of 1 by x is log of mod of x, right? We always write it like this: log of mod of x plus c. And why do we do that? Well, we know that for a log function, if I write something like this, for a log function, the input in place of x, all the input is between 0 and infinity, right? So it's always positive. Therefore, when I integrate 1 by x and I get log of x, I need to, and if we have a negative x here, so therefore log of x cannot be minus x, because it will not be a logarithmic function. Therefore we write log of mod of x. Whatever negative we have here, it will become positive. So therefore every time you integrate something like that, 1 by x or something like that, the integral will always be log of mod of x. So thank you for watching this video, and in the next video I'll be talking about another method of integration, and you can check out my previous video on the integration by substitution. This is the second part of the methods of integration series. Thank you for watching.